Before I get started, this is one tradition that I've kind of started. All right. You guys are all captured in history. My history, at least. And your history now, too. So, before I actually do anything, I want to say thank you guys, thank you organizers to NG Europe for inviting me to come here and speak today. Thank you residents of Paris and all over Europe who have come here to make this a possibility. I have had a grand time in Europe, as I'm sure everyone else here who is not from Europe can say the same. Okay, that being said, I may not need to borrow your phone this time. Okay, with that being said, today I'm going to talk about building games with Angular. A note about this talk is this is a very advanced talk. I'm not going to be talking about, I'm not going to describe too much in detail about Angular itself. I'm going to talk about building a project with Angular. And this project happens to be a game. So I'm not going to dive deep into beginner Angular topics. All the code that I'm running through in this talk is open and available publicly. The link is here in the slides. And if you have any questions as you're going through the code later, or if you have any questions just in general, feel free to reach out. I try to make myself accessible. Additionally, if you're interested and you have a laptop open and you have internet connection, you can follow along with the slides by heading to that URL. Last piece of metadata before we get to the actual talk is who am I? My name is Ari Lerner. I wrote a couple books primarily focused around Angular because I think Angular is pretty rad. NG Book is one of those books. We just released the 1.3 update last week, and we're pretty proud of it. We're pretty lucky to be on an awesome framework. I teach in a couple schools in San Francisco, and I have a server-side background. This is the book, and if you stick around to the end of the slides, or hopefully we make it to the end of the slides, you'll have a code to get that book for cheaper than if you didn't have that code. There's my contact information. I'm a user on Twitter and ari@fullstack.io. Okay, so with that being said, why build a game with Angular? Well, oftentimes games. Oh, that's good. When we talk about games, we generally think about like the actual action of the game, but there's a lot more that goes on in building games, especially production games. Things like heads-up displays, scoring systems, chat inside of your game, user systems, login. What if you want to ensure that somebody pays for your game before they can play it? You need to have something like a paywall. There's a lot more stuff. These are just 7 of the topics I could remember when I was writing the slides. Web applications are really great for doing things like that. We just had a talk not too long ago, like a couple minutes ago, about security. If you want to ensure that when somebody signs up, so that they have an account on the game, this is Angular is really good for doing that. We just saw Ganto stand up here on the seat in the stand of fire, not like the seat of fire one. Anyway, we just saw him live code in front of all of us, and he added security super quickly, of course, with auth 0. Game libraries, unfortunately, are not really great for making chat systems. They're really great for doing pixel manipulation. So this is where Angular plays. Angular is really fantastic for building web applications. I don't need to convince you. You're at NG Europe. You probably already believe that. A question we commonly get when we're talking about Angular, specifically when we're teaching Angular, is Angular is not really good for building games, right? Well, I'm talking about building games on Angular, so you probably already know my opinion. First, it depends on what type of game you're building. Trivia games, board games, card games, trivia games, turn-based strategy, these don't need heavy pixel manipulation. I don't know if you guys have pub quizzes here that are on TVs, but in our chain restaurants in the States, we definitely have these. And Angular is really good for changing specific pieces of data on screen, and we can set timeouts, and we can do scoring on those. These are really easy games to build with kind of just a plain vanilla Angular app, and we don't have to drop into Canvas, and we don't have to drop into WebGL to do that. Thanks to CSS3, we can even provide really fancy 3D or 2D animation. And we don't have to drop down into the canvas. An example of this is on NG Newsletter. It's a blog that I run. The 2048 game is a game just like that. It uses just divs that we move around on screen using CSS. However, this talk would be kind of boring if we were just going to talk about games that are not pixel intense. So let's actually build a pixel intense game. In order to do that, we're going to use Canvas and WebGL. We could either do this natively or we could use a library. There's plenty of libraries that we can pick from. These are just a couple that I like and I use. Phaser and Pixie.js. Phaser is built on Pixie.js. Pixie.js does the canvas. We can use something like 3JS, which is sponsored by Facebook. Unity 3D. However, Unity 3D, in order to deliver our game to the web, we have to pay for it. So I don't like pulling out my wallet to build a game, so I'm going to use Phaser, which is a free open source game framework that works with TypeScript or JavaScript and handles a whole bunch of things for us that we don't have to deal with. Things like sprites, animation, scaling, preloading, stuff like that. So a high-level overview of the game that we'll be discussing today looks like this, where we have our Angular application, and our Angular application isolated from everything else just right in here is just a normal Angular application. Inside of our Angular application, we're going to be building a directive, and that directive will house the Phaser game, and we'll talk about why we do that. And then if we have a chance, if we have time, we'll talk about the server side and how to actually make this real time. So the game that we'll be talking about looks like this. Everything in red, or that's tinted red, is the Angular app, and that big green box is the directive that we'll be building. And it's probably a good idea for me to show a demo of this so we actually know what we're talking about. So this is a demo. I have two browsers open on my computer. They're not the same browser. If I click on one of these, then, ooh, that's a pretty tight window. We can see that we have one player inside of here, and we have another map that shows up. We can shoot here. It's fun. That, by the way, my girlfriend is a voice actor. That's her actual voice. Okay. And then we can make this multiplayer again if we have a chance. So now we can go here and we can shoot that. She kind of refused to do the explosion sound, but so one thing that things to note here is all the pixels that are moving around on screen. This is all Phaser, and you saw this nice little feed that is probably too wide for the screen. That shows up when something in the game actually happens. So that's communicating from the game out to Angular. And then also the friends, which is kind of useless because it doesn't actually show anything. Friends and playing, that's Angular as well. That's an Angular heads-up display. All right. So in order to build this game, we need to know how to build with Angular, or we need to know how to build games with Phaser. So here's a lightning-fast introduction to Phaser. In order to show the lightning-fast introduction to Phaser, we're going to together, if you had your computers open, you could do it with me, build this menu. And that's her voice too. Okay. So we're going to together build this menu. There's a couple things going on with this menu. You can see the background's kind of scrolling up and to the left. We have a little image. This ng invader is an image logo, and we have some text that we can interact with. And when we click on it, stuff happens. All right, so the first thing we need to do when we build a Phaser game is build the Phaser object. The Phaser object, we can do it like this. This is one way to do it, where we call the game object the game method on Phaser, and we pass it the width and the height of the canvas that we're interested in. We can pass it Phaser auto. That will allow Phaser to choose whether or not it uses WebGL or if it uses the canvas. Phaser auto, if we do it like that, Phaser will attempt to use the best. We'll attempt to use WebGL if it's enabled. If it's not, then it'll just fall back to canvas. We can pass it a DOM element, the name of a DOM element, to attach the canvas element on, and then a game object like that. So this is one way to do it. However, this is relatively inflexible, especially when you're building larger games and things with menus and things. So instead of doing it like that, what we can do, instead of passing the game object as an option, we can attach states to the game. So in this case, we're going to do it like this, where we're going to create a menu state, and that menu state will have the different phaser functions that we're interested in using to build our game. And then we just simply need to add it. We need to, is that highlight over there? Oh, cool, it does. We need to add that state, and then we want to call boot on that state. So we'll start that up. OK, so the first function that runs in Phaser when Phaser is called is the init function. However, it's pretty rare you need to use the init function. Instead, we'll use the preload function. The preload function allows us to preload assets before the game starts. This is really important because that menu, we couldn't show ng Invader the logo if that menu showed up until that logo was made available. So anytime that we're building a game that requires assets, it's a good idea to preload them, and Phaser uses the preload function to define what those are. We can load in the preload stage. We can load images like this, that's how we load the fighter in our game. We can load sprite sheets. If you're not familiar with what sprite sheets are, it's basically just a sheet, an image, a single image with a whole bunch of other images on them. In this case, we're loading a sprite sheet that has an animation in it, and this animation has 16 images, each at 128 pixels by 128 pixels, and that looks like this, each of the different phases of that explosion. We can load audio. That's how we loaded the dink sound. We can load fonts, and Phaser even allows us to load any arbitrary scripts. So in this case, if we don't want to package our fonts with our game, we can load from Google Web Fonts and allow that to preload before our game starts. So the create function is called after the preload function. The create function is where it's called once at the beginning of a game and never again called. This is where we'll set up our game. This is where we'll place the background. This is where we'll load the characters that we want to load on screen. This is where we'll do this is like the setup of the game. This is where we'll do all that setup. And then the update loop, which we'll talk about in a minute, is the game loop where the game progresses. So in our menu, we're going to create that background. We're basically using the menu background that we'll load in our preload state. And then we want that background to scroll up and to the left. So Phaser allows us to do that by using a function called autoscroll. It's pretty rad. Then we also want to add that logo, of course, and we're placing that logo in the center of the screen, in the center of the width, and then we're pushing it up just by a little bit from the center. And so that looks like that. That little code. Is that background moving for you guys? Yeah, it is. Okay, great. So now we also need a sprite to actually interact with. So the sprite that we're going to interact with is that text that we click on that says, hey, we want to start a new game. So the way that we can do that is we can use the Phaser's game.add object to add some text to the screen. And the text that we're going to add to the screen is new game. Phaser allows us to pass options with that sprite. We can pass fonts, we can pass the text alignment, we can pass the color. If we want a border on that text, we can do that. If we want an image behind that text, we can pass this inside of here. There's kind of a lot more inside of there. The other thing is that if we are on a different device than just the desktop, right now we're just building for the desktop, but if we were building for mobile, we can place our objects on screen in different ways using a function that's provided by Phaser. By default, we can detect what platform the user is running on. And then lastly, we need to set up some interaction. So when we scroll over the new game button, we want that new game to kind of pop out and be like, hey, you're hovering over new game. When we scroll out, we want that new game to go back to its original position, its original size. And then also, it wouldn't really be a button if you couldn't click on it and something would happen. So we have to add some input there. We need to make sure that we call input enabled on that element. So this is important. If you're building a Phaser game and you're like, why is my thing not working? I defined all the right functionality. yeah, so that whole functionality looks like that. In the over new game function that we demonstrated, we can add these. We can add a tween. And if you're not familiar with a tween, basically a tween will take a beginning parameter and an end parameter. It'll attempt to, over a certain duration of time, it'll attempt to morph the object from the starting to the ending position in something that might look kind of nice. So here in that new game, we're affecting the scale, and we're saying that we want it to grow by 1.3 size of the width and the height, and we want that to take 300 milliseconds, and we want to start automatically. We also probably want to play that audio. Phaser makes this really easy by calling this dot play on that audio element. Great, and with that, then we have our menu.
Tink, tink, tink.
Wicka, wicka. Tink. Okay. All right, so as I mentioned, there's also the update loop. The update loop is called on every single iteration of the game loop. So this is where we'll handle things like, is our player shooting? Our player was shooting in our game, so we need to detect that inside of the update loop and update all the appropriate sprites. We don't need that for our menu. So if you're interested in this code to build that menu, it's all available up here. It's on gist.github.com/auser/something. OK, so enough of Phaser. I think you can just go to /auser and click on the first one, because I just put it up. So now we've covered Phaser. Let's talk about how we get that Phaser game into Angular. First thing we're going to do is we're going to set up our Angular template to look a little bit like this. We're using UI router. So in this, we need to make sure that we're loading Angular, UI router, Phaser, the game library, and also our game as well. So we like to build module-based Angular applications. The benefits of building module-based applications are that we can focus what we want to work on inside of a different module, inside of that piece of functionality inside of a module. It also makes it really easy to test, and we can take code that we write for this game and copy and paste it into another game and use the same code. Or use Git submodules, although I've never had a really good experience with those. OK, so we would create our main application module like this, where we're going to use Browserify, by the way, to require our menu module and our game module. Our menu module looks something like this, where we can define the states that are appropriate for the menu module. In this case, our menu looks a little bit like this. It loads its own template. It has its own controllers available inside the menu module. And then we'll build our game module. And the game module follows the same semantics, where we can manipulate the states that are specific to the game module and not worry about how the menu module works. OK, so I mentioned before that we're going to use a directive to house our application. This is because we're placing an element on the screen. As an Angular developer, if you're ever placing an element on the screen, it's usually a good idea to drop down and place that element in a directive. You have a lot of control over that. So our directive might look something like this. We're building a directive here called game canvas. And this game canvas is really easy. We're defining a single div inside of there with a specific game canvas ID. And this is where we'll place our actual Phaser game. So now once we have the directive placed on screen, we can simply just load that. We can usually just load that game from this point. So we'll write all of our game inside of a file that we'll call main.js. And main.js exposes a function that will get called, or it exposes a single function. So we can call that require, we can call it as a function like that. And we'll pass it 4 arguments. The first argument is the scope of the directive. The second argument are the players. Maybe there's some existing players on that game that we know in Angular. The map ID, because if you saw in our other game, we have multiple maps. And then we'll pass it the injector. And we'll talk about the injector, why we're passing it like that in a few minutes. So in here, we can just simply create the phaser game. As I said before, in order to create a phaser game, we need to call the game function on phaser. We'll pass it the width and the height, and we're grabbing that specifically from the element itself. And then we're saying let phaser choose whether or not it's WebGL or canvas. And then we're passing the ID of game canvas, which is the ID of the element that we want it to attach to. Then we can load our states inside of there, and when the directive has been booted and the main.js has been executed, we want it to start our boot state. One thing to note, because we're doing this inside of a directive, the phaser itself, unless we clean up the phaser object itself, it will never be released. So we need to, when Angular moves away from that screen, we want phaser to take all the things that it's loaded and release those into memory so the rest of the browser can use it. So in order to do that with Angular, we need to listen for the $destroy event. The $destroy event is called by Angular before a scope is destroyed. I said that, that pause was for emphasis. Okay, so inside of here, we just need to make sure that we clean that up. We can, inside of the callback function that's called with this $destroy, we need to call a cleanup on that game object. Okay, so why are we passing the injector into our phaser function? Well, by using the injector, we can directly get access to any services that we need or we're interested in inside the game, outside the scope of Angular. So for instance, if we want to get access to the user service because our user has logged in using maybe Auth0 or a JWT token, and we don't want to deal with that inside of the game, we can do that by simply just grabbing that user service and calling the function that we would call inside of any other part of our Angular application. So how do we communicate between the two? Well, we can use the scope. We can, as you saw before, we can pass either the players in, existing players, or we can use events. So inside of the game, when a ship hits another ship, we can fire off we can emit an event that goes right up to the root scope, and then we're talking from the game to Angular. And if we want to talk from Angular to the game, we can do the same thing, and we can emit functions or we can broadcast functions from the root scope and allow the game to just naturally handle those. All right, so thank you. The game code is available at fullstackio.com/ng-game, and the book, if you're interested in the book that we wrote that's constantly updated, it's at ngbook.com. You can also check out our blog at ng-newsletter. As I said, we have a discount code, that's actually not the right discount code. I'm sorry about that. It's actually just NG Europe. So hopefully you're paying attention. OK, so I have 6 minutes left. Are you guys interested in seeing a rapid fire? How do we make this multiplayer? Yeah? That was not convincing at all. All right. OK. So we are going to be building this multiplayer app. Again, all this code, by the way, is on fullstackio on github/ng-game. We're going to be using a Node and Express with Socket.io, and that's because we're all JavaScript developers. I don't need to describe the language and how it works. There's nothing really special about this server.js, which houses the server-side code. The exception of we are serving the Angular application from Angular. We're using Express static to do that, and we're requiring routes. Where we'll house all of our socket interaction. OK, so that io.js file looks like this, or has lines of code that are in it that look like this. Things to note: we're storing the players that are connected. These are not necessarily players inside of a specific map. These are all the players except all the players available. And anytime that a client socket connects, we're going to attach some events. So let's talk about how we get a new player into the server side. When the game boots up, the first thing that it says is it emits a new player event, and it passes the map ID, the map that we're working in, and the health of the, in our case, the spaceship. So on the server side, we have this onNewPlayer event that gets fired. When this event gets fired, we're going to look up that player that was connected. Again, that was in the list of all the players available in the game. That was the players array. Then we're going to create a map if it doesn't exist with that ID, or we're just going to go fetch it. And then we need to, when we're playing the game, we want to make sure that when a new player joins, everyone else who's already connected to that game gets that new player. So we need to broadcast an event. So the first thing that we'll do when we get a new player event from the new client side is we'll broadcast, well, it's not the first thing, but it's close to the first thing. We'll broadcast that new player to all the rest of the players. And then we need to tell the client that just connected about all the existing players. So when the new player joins, it says, oh, I have these players. OK, so how do we have load socket IO on the client side in a meaningful way? This is kind of a wall of code. Don't worry. This is all up on NG newsletter, and all the code is available on GitHub, as I said before. This is a pattern that I've adopted for using asynchronous modules. This IO loader, basically all that it does is it will load socket IO from a specific location. And when we call the done function inside of our provider, we can ensure that that has been placed in the head of our application. So the two things to note inside of this code is that we are setting that script source like this, and then when that script is ready, when the browser says that that script has been loaded, then we'll call the onScript load. We'll use that like this, where we say we will inject inside of a service, we'll inject that factory that we created. In this case, we called it IO loader. We'll call the done event, and we'll wait for that promise to resolve. Then we know when that promise resolves that window.io is on our window. We would use that to wrap. We can use the window.io wrapped inside of another factory. This is Brian Ford's. If you're not familiar with him, he's pretty awesome. I think he's talking after me. We're using his library in this case. Basically, we're creating our custom socket, and we're passing it the location that we want to connect to. In this case, that's just at the host name of our local host. Cool. So we can use our own service, my socket factory, like this, where now we don't have to worry about loading. All we have to do inside my socket is wait for the promise to resolve, and then we have an available socket. We have a socket that's available to us from inside of there. And we already know that this socket has been connected because of the previous service that we created. That looks like that, if you're going to make it into a picture. OK, so now that we have our socket available to us inside of our game, we can listen for events. If you notice, the event that we fire when a new player connects is called game updated :add. And then basically we're just going to push that new player into an array called remote players on our client side. Excuse me. This is actually a very unoptimized version of this. So check the repo for a much better, more performant version. In order to, when we move our spaceship around the screen, we want that to actually reflect on all the other clients, right? So if we connect to this, we want our spaceship to move around. We would do that inside of the game loop, inside the update function. So this is how we can do that. That update player would look something like this, where we pass the x, the y coordinates, and the rotation, as well as the timestamp. The timestamp is important, but unfortunately, we don't have too much time to talk about that. Basically, without any optimization, you'll just be firing off socket events. And socket IO is not really that fast. So wear fireproof gloves when you're coding, because your computer might light on fire. So rather than doing it like that, we would probably want to control the update timing ourselves. And we can do that using Phaser's game.timeEventsAdd function. All right. So well, it says 0 seconds. Is that hard? Am I going to get shot if I go for 15 more seconds? OK. Real quick, I'm going to wrap up and go a little bit over time. I'm sorry if you guys have a tomato. Please don't throw it at me until I get off screen or off stage. Okay, so what we can do is if we want to communicate back to our application, we can, as we did before where we have this nice little feed when we're saying that we have a player getting shot, is we can fire those events either using something like socket.io as we have up here, or we can use the scope as we kind of mentioned before. So we have multiple ways of communicating between Angular and the game. And with that, game over. I mean, merci, 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 merci. I can say one phrase in French, so I'm going to say it now. La décision, s'il vous plaît. That means I'd like the check, please. All right. So again, ngbook.com is available there. You guys all have a discount code with not that code. Just take out rocks and it works. Cool.